Hi, folks. We're going to take a look at page 403, number 15. So let's see what they're asking us to do. They looking to measure the height of a water tower. Okay, so here it says Kelly walks 0.15 kilometers from the base of the tower. So there's the base of the tower along an inclined path to point P. Okay, so they seem to be telling us that this length here is 0.15 kilometers. Okay. So then they tell us that the tower from point P appears to have an angle of elevation of 12 degrees. Okay, so there's the 12 degrees. And they also gave us the incline that she's walking along, so 8 degrees there. And it says find the height of the water tower to the nearest meter. All right, so here I do have a side length. Okay, and I've got a bunch of angles. I don't have the angle opposite to it. But let me see if I can figure some of this stuff out. Okay, so first of all, we assume that the water tower is going straight up, so we have an angle of 90 degrees. So if this is 8, this is just going to be 90 minus 8. Okay, so 82 degrees. So this is good because now we suddenly have another angle inside, or we actually have one of the angles inside this big triangle. All right, now here, the other thing I see is that, remember that when we talk about the horizontal, when we talk about, an angle of elevation, it's always from the horizontal. So it means that this line here is parallel to the ground, okay? So we have a Z pattern here. So because these two lines are parallel, this incline crosses both of them, that if this is 8 degrees, this must also be 8 degrees, okay? Meaning the total angle here is just going to be 12 plus 8 is 20. And lo and behold, we have two angles in this big triangle, so that means we can find the third, which we need to work with the 0.15. Okay, so let's do here 180 minus 82 minus 20, okay, 78 degrees. So this angle here is 78 degrees. And now we have enough information to solve the problem because we're looking for the height of the water tower. So we're looking for this side. We know its opposite angle. And of course, what's necessary to be able to use the sine law is the fact that we know this side and its opposite angle. All right, so let's set up an equation here. So because I'm looking for a length value, I'm going to use the version that has the length values in the numerator. Okay, so we'll do h over sine of its opposite angle, which we found was 20, okay, equals to the known pair, so 0.15 over the sine of its opposite angle, so sine of 78. Okay, and so here we can easily solve for this by multiplying sine 20 to both sides. So 0.15 sine 20 over sine of 78. All right, let's calculate that here. Okay, so 0.15 times sine 20 divided by sine of 78. And that gives us 0.0524. I think that's enough numbers here. That's a pretty small number, and I do notice that they're looking to the nearest meter. Now, since h was given in kilometers, this is also in kilometers, and we just have to remember that there's 1,000 meters in a kilometer. So we just have to move this decimal place 3 places to the right. So we're left with 52.4 meters. Okay, so quite a high water tower. All right, so just to recap here, solving this problem, once we actually got our diagram all filled in, was actually fairly simple. It was a matter of understanding the diagram. So we had to use a few geometric principles here. So I had to notice that because this water tower is assumed to be going straight up, I had to use complementary angles to find the angle here. I used my parallel line principle to realize that if this was 8 degrees, that angle was also 8 degrees. So I was able to get a second angle in this triangle, and then by using the fact that the sum is 180, I was able to determine the third angle. Then from there, I had enough information to solve the problem, and of course, important to do the final conversion from kilometers to meters. Okay, that's it for this one.